PU2 champions, in today's class we are going to solve the most important questions from the first chapter, that is solutions. And these questions are sourced from previous year questions, question bank and model question paper of the current year. And now let me tell you that this chapter is super easy, and if you just learn 4 to 5 formulas, you can easily attend all the numerical questions. And also if you know the basic theory, basic concepts are clear, then you can also attend the theory questions. So now let us see this particular chapter blueprint, how it is distributed, what is the weightage of this chapter, and so on. So the chapter carries 12 marks. Okay, so definitely a very high weightage chapter. And in this 12 marks, 3 markers will be your 1 marker, that is your MCQs and FIB, and rest 9 marks will be from 3 marker section, means you will get 3 marker questions. And now let me tell you that in this 3 questions, 1 question will be theory of 3 marker, and you will have 2 numerical questions, each of 3 marks, right? So total 9 marks here, and you have 3 marks here, that will give you 12 marks. Now let us see the first question here. So the question is taken from the previous year questions of 22 and 23. 24 and 25 questions are already included in the question bank, so I have not considered it separately. So let us see here the first question. A binary mixture that forms maximum boiling azeotrope at a specific composition is. Now maximum boiling azeotrope is given by what? Negative deviation, right? If you have negative deviation, then there is strong attraction and it takes a lot of time to boil the solution and the boiling point increases. So which of the following will have a maximum boiling azeotrope? So you need to find something which is having negative deviation, right? So nitric acid and water shows negative deviation. There's very strong attraction here. So that is why option number D here. Next, the Van der factor of ethanoic acid in benzene. So if you know, ethanoic acid in benzene undergo association, or you can say dimerization, right? So benzoic acid, like what is the value of I? I is number of particles before association or dissociation, sorry, number of particles after dissociation divided by number of particles before dissociation. So 2 molecules of benzoic acid, 2 molecules of ethanoic acid will form 1 molecule. Means once you have added them, it will become 1 by 2. So the value here is 0.5. That is option number C. Next, because of low concentration of O2 in the blood and tissues of people having at higher altitude, they suffer from a disease called anoxia. Right? When you have higher altitude, the solubility of oxygen is very low. So that medical condition is called as anoxia. Now let us move to the next question. So you know from this chapter definitely a numerical questions will be asked. So let us see, 450 centimeter cube of an aqueous solution of protein contains 1 gram of protein. The osmotic pressure of a such solution at 310 Kelvin is found to be 3.1 into 10 to the power of minus 4 bar. Then calculate the molar mass of the protein. The R value is given to you. Okay. So osmotic pressure formula is what? If you know, osmotic pressure is equal to C into R into T, where C is molarity. So how you can write molarity? Given mass by molar mass into 1000 by volume into R into T. Right. Now the question has asked you to find out what? To find out calculate the molar mass of the protein. You have to find the molar mass of this protein. So what I can do? M will be equal to, as you can see, W into 1000 by volume in ml divided by R into T, and here I can have pi value, right? Or you can simply convert the volume here only to liter, so you don't have to multiply this 1000. So I have done it like this. So I have written here volume in 1000 in liter. Okay, so now let us substitute here. So you can see that what is the value of W, means how much gram of the sample is taken? 1 gram. So I can substitute here W equal to 1. Then R value is 0.083. Temperature is 310 Kelvin. Then pi value is how much? 3.1 into 10 to the power of minus 4. And volume is 450 ml, right? 450 ml can be converted to 0.45 liter. So we have 0.45 liter. Now if you solve this, you will get 18444 gram per mole. Now you don't have to worry about calculation at all. You just need to know the correct formula. Then you can easily calculate, because calculator is allowed for your exams. Now moving to the next question, that the state Raoult's law of relative lowering vapor pressure and write its mathematical form. State Raoult's law. So what does Raoult's law says? That in a solution containing a non-volatile solute, okay, if you have a solution containing non-volatile solute, then the relative lowering of vapor pressure is equal to the mole fraction. Okay, sorry, just a minute. State the Raoult's law of relative lowering of vapor pressure, right? Okay, correct. So the Raoult's law states that in a solution containing a non-volatile solute, the relative lowering of vapor pressure is equal to the mole fraction of the solute in the solution. Okay, relative lowering of vapor pressure is equal to the mole fraction of the solute, right? So that is what is Raoult's law of relative lowering of vapor pressure, and you can mention all the terms here. What is P naught A? P naught is the, I can say, pressure of pure solvent A. Okay, then you have PA, that is equal to partial pressure of A. Okay, then you have NB, that is number of moles of B, Na is number of moles of A, and NB is number of moles of again B. Now next question, we'll move to May 2023 paper. So which of the following is a colligative property? So you can see osmotic pressure is a colligative property. Next, which of the following term is dependent on temperature? So this is very important question. Molarity, if you see, what's the formula of molarity? It is number of moles by volume in ml into 1000. Right? Now when the temperature changes, if temperature will increase, volume will also increase and molarity will decrease. So we can say that the molarity is dependent on temperature. So that is why the correct answer here will be option number A. Next, low blood oxygen causes climbers to become weak and unable to think clearly, symptoms of which is known as. So again, low blood oxygen, the climbers, the same thing, it is the condition of anoxia. Okay. Now let's move to a question here, numerical part. 1 gram of a non-electrolyte solute dissolved in 50 gram of benzene lowered the freezing point by 0.4 Kelvin. The freezing point depression is given to us. Find the molar mass of the solute. Now if you see what is the mass here, mass is 1 gram, right, of a non-electrolyte solute dissolved in 50 gram of benzene. So WA is how much? 50 gram of benzene lowered the freezing point. So delta TF is equal to 0.4 Kelvin. The freezing point depression constant Kf is equal to 5.12 Kelvin kilogram and mole inverse. Find the molar mass of the solute. You have to find the molar mass of the solute, right? Now what is this formula we have? Delta TF is equal to Kf into M. Now how can I write this Kf into M? The molality here is given mass by molar mass into 1000 by mass of the solvent. Okay. Now Kf value, if you see what is the value of Kf, that is 5.12. Wb is 1 gram. Mb, it is that which we have to find out, right? Into 1000 by Wa, the mass of the solvent is 50 grams. And the delta TF value is 0.4. Now if I solve this, you will get 256 gram per mole. That is the molar mass of the solute. Now let's move to the next question. Define the Van't Hoff factor I. Give the value of I for complete dimerization of ethanoic acid in benzene. Okay. So what is Van't Hoff factor? Van't Hoff factor is the ratio of normal molar mass to the abnormal molar mass. Okay. And I can also be written as the formula normal molar mass divided by abnormal molar mass. And for benzene dimerization, the I value is 1 by 2. Okay. Next, we'll go to 2022 March PYQs. Mention one practical utility of reverse osmosis. So that is used in the desalination of seawater. Next, at constant temperature, different gases have different KH value. What does this statement suggest? So that is Henry's law constant depends on the nature of the gas, or different gas have different solubilities. Okay, different gas can, the solubility of the gas in a solvent depends on its nature. So based on that, we have different KH values. Next, define molarity and how does molarity vary with temperature? This is very important question. So molarity is the number of moles of solute dissolved in 1 liter of the solution, and molarity varies inversely with temperature, because if you see the molarity formula is number of moles by volume. If temperature increases, volume will increase and molarity will decrease. So we can say that molarity and volume are inversely proportional. Next, we'll talk about question number 4 of March 2022 again. So on dissolving 3.46 gram of a non-volatile solute in 100 gram of water. So what is the value of W here? 3.46 gram of a non-volatile solute in 100 gram of water. Okay, the boiling point of solution was raised by delta TB is equal to 0.12 Kelvin. Calculate the molar mass of the solute. Okay, given Kb value is there, that is 0.51 Kelvin kilogram mole inverse. Okay, so now let us find out this value. Delta TB is equal to Kb into given mass by molar mass into 1000 by W. Okay, now delta TB is what? 0.12. Kb value is 0.51. WB is how much? 3.46. MB is what I have to calculate into 1000 by WA is 100. Okay, now if I solve this, MB value will get is 147.05 gram per mole. Now let's move to the next question. What type of deviation from Raoult's law is observed when equal volumes of ethanol and acetone are mixed? Okay, mention the reason. So first of all, what type of deviation? Ethanol and acetone shows positive deviation. Okay, this is because see, acetone breaks some of the hydrogen bonds of ethanol, decreasing the ethanol-ethanol interactions. See, ethanol is an alcohol molecule. Two ethanol molecules have very strong hydrogen bonding. But now when you add this acetone in that, the hydrogen bonding is disrupted and there is no bond, a good strong bond between acetone and ethanol. So that is why overall the interaction decreases and we saw positive deviation in this case. Now let's move to July 2022. State Henry's law. This is again very important question. So Henry's law states that the solubility of gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. What is that? The solubility of a gas is directly proportional to the partial pressure of the gas above the liquid. And when I write it to remove this proportionality, we get this particular equation. Okay. Next question, sodium chloride solution having a concentration greater than 0.9% is not safe for injection, not safe for inject intravenously, give reason. Okay, now if you see the cell that we have, okay, it has 0.9% of sodium chloride solution. And that is why there's osmotic pressure related to this 0.9%. Now if you add any injection, okay, which is having greater than 0.9%, okay, that means what? This one is more concentrated, and this one is diluted. So what will happen? Water will start flowing from here, exosmosis will happen and the cell will shrink. So that is why that is not safe. So we can write because the blood cells will shrink because the solution is hypertonic. Next question, give two differences between ideal and non-ideal solution. Super important question. Ideal solution obeys Raoult's law. Okay, then it does not obey Raoult law. B mix is equal to 0, here not equal to 0. Delta H mix is equal to 0, here not equal to 0. Here AB interactions are equal to AA and BB, here it is not equal. It can be either greater or less than AA and BB. Next, there's a question on the numerical. 31 gram of unknown material is dissolved in 500 gram of water. So what I can write, WB is 31 gram and WA is 500 grams. The resulting solution freezes at 271.14 Kelvin. So T naught F is obviously 273 Kelvin, but I have here TF which is equal to 271.14 Kelvin. Next, calculate the molar mass of the material. Calculate the molar mass and the value of Kf is 1.86. Okay, so now how to calculate this one? See, you have delta Tf is equal to T naught F minus Tf is equal to Kf into given mass by molar mass into 1000 by mass of the solvent. Okay, now delta Tf value is how much? 273 minus Tf value is 271.14 is equal to Kf value is 1.86. WB is 31 gram, right? MB I have to calculate into 1000 by WA is 500, right? So if I solve this, you'll get the value of X as 62 gram per mole. Clear? Fine. Next question is, what are azeotropes and which type of azeotrope shows large positive deviation from Raoult's law. Okay, so first of all, what are azeotropes? So azeotropes are binary liquid mixtures having the same composition in the liquid and vapor phase, and they boil at a constant temperature, are called as azeotropes, right? They have the same phase in the liquid as well as in the vapor phase, and they have the same boiling point. Now for positive deviation, we have minimum boiling azeotrope. Okay, so students, I'm not going to explain these questions, very direct question. Already I have given you the one shot revision video where I have explained you the concepts, right? So here only I'm telling you what type of questions are asked, okay, so that you can be prepared for that. So if you have understood that positive deviation is weak interactions, right? If weak interactions, then the molecules can evaporate easily, and that is why the boiling point will decrease. Next, we'll do questions from question bank. Okay, now this question bank is very important. Okay, a lot of questions have been asked, and yes, I have although taken very selected questions, but still a lot of questions are covered. So please watch this video. Question bank especially you need to solve thoroughly. Okay, so let's see the first question here. Differentials between molarity and molality of a solution. How does a temperature change influence their values? So next one. Okay, let us see the first third question. So what is molarity difference? It is the number of moles per liter of the solution, the general definition, and molality is the number of moles per kg of the solvent. Next, how does a change in temperature influence their value? So effect of temperature, molarity changes with temperature because volume of the solution changes, whereas molality is independent of temperature since mass does not change. Okay. Next, which aqueous solution has higher concentration? 1 molar or 1 molal aqueous solution of the same solute? Give reason for the answer. So it is 1 molar solution is one which is having more concentration. Why? Because see, in 1 molar, what you take the formula, you can see 1 molar solution has higher concentration. Reason is, see, 1 molar is equal to 1 mole of the solute in 1 kg of solvent. 1 molar is equal to 1 mole of solute in 1 liter of solution, and in the solution you include solute as well as solvent. So since the volume of solution is more than the volume of solvent alone, so if you see, I can suppose this is a solute. Okay, this much solute, sorry, 1 second, this much solute is present, and when I talk about molality, this much solute is present in, suppose, this much amount of solvent. But in case of molarity, what will happen, that much amount of solute will be present in more amount of the solution, because here both solvent and solution is increased, right, is both considered. So what will happen, there will be a, I can say, dilution factor. You can consider here more amount of solvent is present, solution is present. So that is why what I can say is 1 molal contains more solute per comparable amount of solvent. Next is, what is the effect of temperature and pressure on the solubility of solid in liquid, and effect of temperature and pressure on the solubility of gas in liquid. So first of all, we'll talk about the solubility of solid in liquid. For temperature, if the dissolution process is endothermic, then it increases with the temperature, and vice versa. If it is exothermic, then it will decrease with the increase in temperature. And pressure has no effect in the solubility of solid in liquid. Now coming to solubility of gas in liquid, temperature, if you increase the temperature, solubility will decrease, and for pressure, if you increase the pressure, solubility will increase. Next, we have dissolution of CaCl2 in water is exothermic process. Meanwhile, that in ammonium nitrate is endothermic process. What is the effect of temperature on the solubility of these two solutions? So if you see CaCl2 is exothermic, means if you decrease temperature, solubility will increase. And in case of ammonium nitrate, it is endothermic, means if you increase the temperature, solubility will increase. So you can write down, for CaCl2, it will decrease with the increase in temperature. So if you're increasing the temperature, since it is an exothermic process, the solubility will decrease. In case of aluminum nitrate, it will increase with the increase in temperature, since this is an endothermic process. Next, what is the expression? Write the expression, the solubility of gases in water related with their Henry's constant at the same pressure and temperature. So you have pressure is equal to Kh into X of the gas. So that is your Henry's law statement, mathematical statement. Next question, at the same temperature, hydrogen is more soluble in water than helium. Which of them will have a higher Kh value? So if you see, we have this formula P equal to Kh into X, right? X of the gas is considered as solubility, right? X is a term for representing solubility. So what I can write, X is equal to P by Kh, right? X is equal to P by Kh. So what do you make? If higher solubility, then Kh value will be less. If Kh value is more, solubility will be less. right? So we can say that at same temperature, okay, hydrogen is more soluble in water than helium. What I'm saying, hydrogen, okay, is more soluble than helium. That means what? KH value of hydrogen is less than the KH value of helium, right? So whichever is more soluble will have less KH value. So obviously, what is the answer here? Answer is higher values for helium. Next, mention any two applications of Henry's law. Okay, so applications of Henry's law we have already studied in the one shot video. The first application is the carbonated drinks, right? Henry's law is saying what? More the pressure, more is the solubility, right? So the first application here is definitely the carbonated drinks. So if you remember, here they have asked you two, but I have given you all the three, so that because in 3 marker question they will ask you 3 applications. So in the manufacture of soft drinks and soda water, solubility of carbon dioxide is increased by applying pressure. If you apply more pressure, more solubility will be there. Next is the scuba diving, right? What happens when the scuba divers go deep down the oceans or seas? The pressure increases, the solubility of gas in their body increases. So what happens when they come out? The solubility keeps on decreasing, and the nitrogen gas which is dissolved in the blood comes out in the form of bubbles, and these bubbles can actually block your vessels and can cause a medical condition, bends. So to prevent this particular condition, the oxygen cylinders of the scuba divers are mixed with helium. Okay, so to minimize the painful effects of bends accompanying the decompression of deep sea divers, oxygen diluted with less soluble helium gas is used as a breathing gas. So with oxygen, some helium gas is also added, because helium KH value is very high and it is less soluble in the blood. Next we have all altitude. At higher altitude, what happens as we go, the mountain climbers and all, as we move higher, the pressure decreases, right? So the solubility of oxygen gas will decrease. Now if the solubility of oxygen in the body is less, in our bloods there will be less oxygen, and then the brain, when the blood carries to oxygen to the brain, that will be less, means the oxygen in the brain will be very less and brain cannot function properly, and this particular leads to a medical condition called as anoxia. Okay, so these are the applications. Next, question number 4. Why do gases always tend to be less soluble in liquids as the temperature increases? So see, dissolution process in gas is an exothermic process. Okay, so if you increase the temperature, definitely the solubility will decrease. Okay. Next question, define vapor pressure of a liquid. Name the law which helps us to determine the partial vapor pressure of a volatile component in the solution. So vapor pressure is the equilibrium pressure of the vapor above its liquid or solid state. Now let me explain you vapor pressure once again. See, if you have a closed container here, okay, there is some liquid here, this will evaporate and they will create vapors here, right? So these vapors will go hit the container and then they will condense. So you can see that there is two processes happening, evaporation and condensation, right? So the point at which the rate of evaporation and rate of condensation is equal, that is called as the point of equilibrium, right? So at equilibrium position, whatever is the vapor pressure or what is the vapor created, the pressure exerted by these vapors on the solution is called as vapor pressure, right? So that is why vapor pressure is the equilibrium pressure. Okay, means there is an equilibrium attained. So the vapor pressure is the equilibrium pressure of the vapor, of these vapors, equilibrium pressure of the vapors above its liquid or solid state. Now which law helps us to calculate? It is the Raoult's law. Next, 16th one, what happens to the vapor phase when a volatile solute dissolves in the liquid? So if you have a volatile solute dissolved in the liquid, then it depends on the interactions, A-B interactions. If due to this A-B interactions, it may be increase or it may decrease, positive and negative deviation we can have. But if it is a non-volatile solute, then definitely the vapor pressure will always decrease. Okay. Next, what is the effect of, okay, I think this question we have already done. What is the effect of temperature? This is discussed, right? Already discussed. Okay. So now let us discuss the 3-mark questions. The first one is name the two components present in a binary solution. Very simple. What are the two components? You have solute and the other component is solvent. Next, which component determines the physical state of binary solution? That is determined by the solvent. Okay, if the solvent is liquid, then we call it as a liquid solution. If the solvent is gas, then it is called a gas solution. Okay. Now, you have column 1 and column 2, you have to match it. Okay, what is a saturated solution? A saturated solution is that solution where you cannot dissolve more solute. Okay, so what is it? A solution which contains maximum amount of solute that can be dissolved in a given amount of the solvent at a given temperature. Okay, so one will be F. I'm not putting here, it will become dirty, so I'm just writing here one will be F. Next, binary solution. A solution having two components is called as a binary solution. So 2 is E. Next, what is isotonic solution? Solution having same osmotic pressure at the given temperature. So 3 is B. Next, 4, what is hypotonic solution? A solution whose osmotic pressure is less than that of the another. Okay, so fourth one is D. Next, fifth is what is solid solution? A solution in the solid phase. So fifth one is A. And then sixth, what is hypertonic solution? A solution whose osmotic pressure is more than that of the other. So 6 is B. Okay, 1F, 2E, 3B. Okay, 1 second. Oh, sorry, 6 is C. Okay, sixth one is A, solution whose osmotic pressure is more than this one. So 1F, 2E, 3B, 4D, 5A and 6C. Next question, name any three parameters which affect the solubility of gas in a liquid. So three parameters: temperature, pressure and the nature of the gas. Pressure, solubility of gas is directly proportional to pressure, temperature inversely proportional to temperature, and the nature of the gas and the solvent. Next, state Henry's law. Already we have discussed, write it mathematical form. What is the significance of Henry's constant? Significance of Henry's constant is if KH value is more, then solubility will be less. Right? Next, mention three applications of Henry's law. That also we have discussed. So you can see here Henry's law statement: the solubility of gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. And Henry's constant is inversely proportional to the solubility of gas. Next, question number 8. Derive its mathematical expression of vapor pressure for a solution of a non-volatile solute in a volatile solvent. Okay, so what is the vapor pressure? See, if you have a component like this, okay, and here this is a solvent and you have a, what I can say, non-volatile solute. So what will happen? The vapors will be created here of the volatile solvent. So I can write that P total, okay, is equal to pressure of A, partial pressure of A. Why? Because B is not evaporating, B is a non-volatile solute. So PA, and PA can be written as P naught A into XA. So P total will be equal to P naught A XA. So how can I derive it? Okay, just a minute, you have to just derive this one and you have to show this. So you can see here, see, let a solution contain a volatile solvent A and a non-volatile solute B. According to Raoult's law, the vapor pressure of the solvent A in the solution is equal to P naught A XA, where P is the partial vapor pressure of solvent in the solution, mole fraction of the solvent, and vapor pressure of pure solvent. Since B is non-volatile, the total vapor pressure of the solution, here this P represents the total vapor pressure. Okay, the total vapor pressure is equal to pressure of A, which is equal to P naught A XA. Okay. Next, draw a suitable level diagram to express the relationship for ideal solution A and B between the vapor pressure and mole fraction of components at constant temperature. Okay, so you can see here suitable level diagram if I can draw. This is how it is done: x1 to x0, the, what I'll say, the pressure is decreasing. So you can see here a graph like this. X2 is equal to 0 to x2 is equal to 1, the pressure is increasing, and you can see a graph like this. And P total is equal to P1 plus P2. Okay. Next, 10 is state Raoult's law, write the conditions necessary for a solution to show ideal behavior. Okay, so state Raoult's law we have already discussed all previously. What are the conditions necessary for the solution to show ideal behavior? So conditions that are required is PA should be equal to P naught XA, or PB should be equal to P naught BXB, or you can write P total should be equal to P naught AXA plus P naught B XB. Okay, then delta H of the mix should be equal to 0 and delta V mix should be equal to 0. Next, what are ideal and non-ideal solution? Give reasons for the formation of such solutions and give one example in each case. So, and what are the different, okay, so question number 11, you can see here. Okay, what are ideal and non-ideal solutions? We have also discussed this difference between previously, right? So this is already discussed. So then we'll give reasons for the formation of such solutions. So the reason here is the interactions. Interactions between A and B. If AA and BB interactions is equal to AB interactions, then we get ideal solution. If it is not equal, then we get non-ideal solutions. Give an example in each case. You can write down what are the examples. So let me just write down the answer here. The second part, give reason. What is give reason? What will you write? What is the reason for that? So if AA and BB interaction is equal to AB interaction, okay, then we get ideal solution. You can write it in full words. If AA and BB interaction is not equal to AB interaction, then we get non-ideal solution. Okay. Now, what is there? Give one example in each case. So if you want to write the example in each case, okay. So for ideal solution, you have the example of N-hexane and N-heptane. Okay. And for non-ideal, you can have many example. You can write acetone and ethanol. Okay, many examples are there. You can write any one. Next, different types of non-ideal solution, that is your positive deviation and negative deviation. So that you have to write down very clearly. So positive deviation is what? The new AB interactions are weaker than AA-BB interactions. Whereas negative deviation, new AB interactions are stronger than AA-BB interactions. Here PA is greater than P naught XA, PB will be greater than P naught B XB, and the total pressure will be equal to P naught XA plus P naught B XB. Next, here PA is less than P naught XA, PB is less than P naught B XB, and the total pressure will be less than P naught XA plus P naught B XB. Then here delta V mix is equal to 0, delta V mix is less than 0, delta H mix is plus greater than 0, here delta H mix is less than 0. Examples, you can see here many examples are there: ethanol in water, chloroform and acetone. Okay, other examples also you can note down. Next, explain positive and negative deviation from ideal behavior, already done. Give any three differences between ideal and non-ideal, done. Give any three differences between solution having positive and negative deviations, that is also discussed. Okay. Next, moving to question number 16, mention the following types of liquid solution with their characters. Okay. So ideal solution, what will be ideal solution? PA will be equal to P naught A XA, right? So this one will come here. Delta H mixing is equal to 0 and delta V mixing will also be equal to 0. Non-ideal solution with positive deviation, the pressure PA is greater than P naught A XA, delta H value is positive and V value is also positive. Non-ideal solution, the PA is less than P naught A XA and value is negative here and negative here. Next question is, write what are colligative properties. Name the colligative properties expressed in terms of mole fraction and write the mathematical equation of that colligative property. In terms of mole fraction, that is your relative lowering of vapor pressure, right? So first of all, what is colligative properties? Properties of the solvent which depend on the number of moles of the solute and not on the nature of the solute is called as your is called as your colligative properties. Next, what is the mathematical equation here? So first of all, which colligative property is used in terms of mole fraction? That is RLVP, or you have to write down the full word, that is relative lowering of vapor pressure. Next, this value P01 minus P1 by P01 is equal to N2 by N1 and N2. That is your formula. Okay. Next, show that the relative lowering of vapor pressure for a solution, so that the relative lowering of vapor pressure for a solution is equal to the mole fraction of the solute when solvent alone is volatile. Derive an expression to express the relative lowering of vapor pressure for a solution is equal to the mole fraction of the solute in it when the solvent is alone volatile, right? So we have to prove that relative lowering of vapor pressure is equal to mole fraction of the solute. We have to derive that. So what is this relative lowering of vapor pressure? See, delta P is what? P naught minus P, okay, or P naught of A minus PA. That is your delta P. Means initially when you have only solvent, you had some pressure of A. Now when you added some solute, now we have the partial pressure of A. So when you add a solute, the vapor pressure decreases. So what is the change in the pressure? P naught A minus PA, that is your delta P. Now from the Raoult's law, I can write this one, P naught A is minus, PA can be written as P naught A into XA. Right? Now from here, can I take P naught A common? So I'll get 1 minus XA, right? And you know 1 minus XA is nothing but XB, and here I have delta P, right? So delta P by P naught is equal to XP. Or if I just expand this delta P, I'll get P naught minus P by P naught is equal to XP. Okay. Next question. So graphically, how the vapor pressure of a solvent and a solution of a non-volatile solute change with temperature. So on this graph, the boiling point of the solvent and the solution, which is higher, and give reason for your answer. So first of all, you need to draw this graph, okay, where you can see that the vapor pressure is proportional to temperature. As the temperature increases, the vapor pressure increases, but the vapor pressure of the solvent will be more than the vapor pressure of the solution, right? So that is why you can see this is the vapor pressure of the solvent and it is more than the vapor pressure of the solution. So that we have done. Then show on the graph the boiling points of the solvent and the solution. Okay, so boiling point of the solvent, you can see that this is this line. Okay, this line represents what? This is the atmospheric pressure. Okay, this is the atmospheric pressure. So when the vapor pressure of the solvent and solution touches the atmospheric pressure, then that point is called as the boiling point. So here we have boiling point of solvent T naught B, and here we have boiling point of the solution, that is Tb, and the difference between these two is called as delta Tb. Okay, and which is higher? As you can see from the graph, the boiling point of the solution will be higher. Now what is the reason for that? See, when you add a solute, so what is boiling point? How do we define boiling point? Boiling point is that temperature at which the vapor pressure of solution is equal to atmospheric pressure, right? Now you see this is the atmospheric pressure line. Okay, when you have a solvent, it was touching here, but when you have added a solute, the vapor pressure is now decreased. So now you will require more, you need to create more vapor pressure to reach to the atmospheric pressure value. So that means you need to heat for more time and the boiling point will increase. So how will you write the reason? The boiling point of the solution is higher, that's the this part of the question, that which is higher, and the reason: vapor pressure of the solution decreases on addition of a solute. To make the vapor pressure of the solution equal to that of the atmospheric pressure, we need to heat it more, and hence the boiling point increases. Okay. Next, define the term molar elevation constant and molar depression constant and give their SI units. So molar elevation constant, if you know the formula, delta TB is equal to Kb dot m. This Kb is called as molar elevation constant. Delta Tf is equal to Kf dot m, and Kf is called as molar depression constant. So if the increase in boiling point is 1, okay, it is the increase in boiling point of a solution when 1 mole of a non-volatile solute is dissolved in 1 kg of solvent. Okay, so when the molality is 1, whatever the increase is happening, okay, in the boiling point, that is called as your Kb value. Similarly, if you see, it is the decrease in the freezing point of a solution when 1 mole of non-volatile solute is dissolved in 1 kg of solvent. So when 1 mole of non-volatile solute is dissolved in this one, and whatever is the depression in freezing point happens, that is called as your molar depression constant. Next SI unit is Kelvin, kilogram, mole inverse. Okay. Next, moving to question number 22. With the help of vapor pressure temperature diagram, explain the depression of freezing point of a solution of a non-volatile solute in a volatile solvent. How would you determine the molar masses of the solute using the above properties? So again, the same thing. What is freezing point? You need to understand. See, freezing point is that temperature at which the vapor pressure of the solvent, okay, vapor pressure of the solid solvent is equal to vapor pressure of liquid solvent. Okay, now when you add a solute, this vapor pressure of liquid solvent, when you add a solute, it has now become a solution, right? So vapor pressure of the solution is less. Okay, so now you have to go beyond the normal freezing point to reach the vapor pressure of the solid solvent. So I can show you in the graph here. So let us see the graph here. You can see this is the vapor pressure of the solvent, right? And this is the vapor pressure of the pure solvent. This is for the solid solvent, this is for the liquid solvent. This point where they are meeting is the freezing point of the solvent. Now when you have added a solute, the vapor pressure will decrease, and now this value, okay, this point where it is touching the frozen solvent, that is called as the TF value, T naught F and TF value. This difference is called as delta TF. Okay. Now a solution will freeze when its vapor pressure equals to the vapor pressure of the pure solid solvent. Okay. The solution will freeze when the vapor pressure is equal to the vapor pressure of the pure solid solvent. Now according to Raoult's law, when a non-volatile solid is added to the solvent, its vapor pressure decreases and now it would become equal to that of the solid solvent at a lower temperature. Okay. Now when you have added a solute, the vapor pressure has decreased and now it will be equal to this vapor pressure at a lower temperature, and that is why the freezing point decreases. Next question. Yes. What is a semi-permeable membrane, and give an example each of a natural and a synthetic membrane. So semi-permeable membrane is a membrane which allows only the movement of solvent particles from one region to another and not the solute particles. Natural example is parchment paper and cellophane paper, and artificial is a film of gelatinous precipitate of cupric ferrocyanide. Next, write 3 reasons to justify that osmotic pressure has an advantage over the other colligative properties. So the first is it is carried out at room temperature. Second is it uses molarity instead of molality. Next, as compared to other colligative properties, its magnitude is large even for very dilute solution. Means if you have a very less concentrated of the sample also, the value that you calculate will be higher, and then you can easily get the answer. You can easily calculate the molar mass of the solute. Next is 25. Again, write 3 reasons to justify. Same question. Okay, here one question was there that I think we have not. How do you determine the molar mass of the solute using the above properties? So here what you have to write, delta TF is equal to KF dot WB by MB into 1000 by WA. Right. So in this way, you can calculate the molar mass of the solute by using this formula that you have to write down. Okay, next. Okay, we have discussed, yes. 26th question, what is an isotonic, hypertonic and hypotonic solution? So isotonic solution means two solutions having the same osmotic pressure. Hypertonic means solution having higher osmotic pressure than the cell fluid. Suppose your reference is cell fluid. If the outer solution is having more osmotic pressure, then it is called as hypertonic. Solution having lower osmotic pressure than the cell fluid is called as your hypotonic solution. Next question is comparison here. The osmotic pressure fluid inside the blood cell is of 0.9% NaCl solution. What happens when the blood cell placed in the, okay, first one is 0.9 NaCl solution. So inside osmotic pressure is also due to 0.9 m by v NaCl. Outside also same concentration. So that means both the solutions are isotonic. So there will be no osmosis and the cell remains as it is. Now if you have greater than 0.9 mv NaCl, here is the cell, and suppose here you have what? 0.9% m by v NaCl solution. Means it is more concentrated. So if it is more concentrated, what will happen? The cell will flow from here to here. Okay, there is exosmosis. Okay, and the cell will shrink. Now if it is less than 0.9%, if the value here is less, okay, here the cell is there and the value here is less, then what will happen? Here all the, means the outer one is having lesser concentration, the cell is more concentrated, then water will flow inside the cell, endosmosis will happen and the cells will swell. Okay. Next, what is reverse osmosis? Mention one of its practical use and give an example of artificial cell membrane or semi-permeable membrane. Okay, so reverse osmosis means what? The direction of osmosis can be reversed if a pressure larger than the osmotic pressure is applied on the solution side, and that is now the pure solvent flows out of the solution through the semi-permeable membrane, and this is called as reverse osmosis, where it is used in the desalination of seawater. And example of a artificial membrane is your cellulose acetate. Next question is to match the following. You have isotonic solution, then it will be equal to 0.9% and there will be no effect and there will be no change here. Hypertonic solutions means greater than 0.9%. So if it is greater than, water will flow out of the cell and the cell will shrink. Hypotonic means it is less than 0.9%. So water will flow into the cell and the cells will swell. Okay, now let us see the next question, that is question number 30. What is abnormal molar mass? We have already discussed. Define Van 't Hoff factors, already discussed. What would be the value of Van 't Hoff factor for a dilute solution of K2SO4 if it undergoes complete dissociation? K2SO4, 2 potassium and 1 sulfate ion. So Van 't Hoff factor here will be 3. Next, why do electrolytes show abnormal molecular masses, and name the factors responsible for abnormality? So electrolytes shows abnormal molecular mass because they either dissociate or associate when they dissolve in a solvent, right? You get different values that they can either undergo dissociation or they can undergo association, and this increases the number of particles in the solution. So colligative properties can be either higher or lower than the expected value. Okay, now what are the factors responsible for abnormality? It is dissociation and association. Next is based on the nature of the compounds, assume that the compound will undergo either 100% association or 100% dissociation. Compare these values with their Van 't Hoff factor. So K2SO4, just now we have discussed, this one will be 3. So option number 6 here. NaCl will be 2. So option number 3 here. FeCl3 or K3FeCN6. So if you 3 K3FeCN6, right? So you will get 3K plus, and this FeCN6 will remain as it is. Okay, so total number of ions you get here is 4. So that is why this is option number 4. Next, K4FeCN6. So this one will be 5. Okay, because you can also have aluminium sulfate. So 2 aluminium and 3 sulfate. So this is 5. Now acetic acid in benzene, that will be 0.5. So 1. And urea or glucose, since it is a non-electrolyte, it will not dissociate. So the value here will also be 1. Okay, okay. Here one second. 5 is in option number 2. This is option number 2. Okay, K4FeCN6, you will get 5 ions, so that is option number 2. Next, this one, urea or glucose will be non-electrolyte, it will not dissociate, so that is 5. Next, we'll talk about some give reason 1 marker question. Now, your question may arise, ma'am, why 1 marker question? See, in the last year model papers and last year half yearly and pre-board papers, the 3 marker question that comes right in the 3 marker section, it was like 3 questions having the reasoning questions have been asked. Means one like 3 reasoning questions, 3 marks, each question carries 1. So like that the question was asked. So that is why we in this particular video will be solving this 3 marker, like for that 3 marker we'll be solving some reasoning questions, basic questions 1 marker that you should know. This can be clubbed, 3 reasoning questions can be put in 1 question and can asked in the 3 marker question. Okay, so let us see the first one. The first one is the molality preferred over molarity in handling solutions in chemistry. So why do we prefer molality? The basic reason here it is independent of temperature. Okay. Next, the molality of a solution remains unchanged with temperature. The point here is because it depends on the mass of the solvent and not on the volume, and mass does not change with temperature. Next, here we have carbon tetrachloride and water are immiscible, whereas ethanol and water are miscible in all proportions. So here it is the like dissolves like concept. So water is polar and carbon tetrachloride is non-polar and water is polar. So that is why they do not mix, whereas ethanol can form hydrogen bond with water and it is also polar. So that is why it is completely miscible in water. Next, aquatic species like fish feel more comfortable in the lakes in winter than in summer. So you know, if the temperature is less, solubility of oxygen in water increases at lower temperature. Less is the temperature, more is the solubility of gases. So fish will get more oxygen, so that is why they are more comfortable. Next, when cold drink bottles are placed in salt to the box containing ice, cold drink bottles are cold for a longer time. Yes, so if you are having a box of ice and that in that ice if you have added some salt, then the cold drink bottle will remain cold for a longer period of time. So what is the reason for that? See, when you add salt, it lowers the freezing point of the ice, causing more ice to melt and absorb the heat. Okay, so now what will happen? See, if the now suppose this was the container, okay, here ice was present and here you have added some cold drink bottles. Now when you add salt, what will happen? These will start melting because now their melting point is not 0 degrees Celsius, their melting point is less. So when they will start melting, what they will do to melt, they will absorb heat. Now they will absorb heat from the surrounding and the surrounding will become cooler, and the ice and your cold drink bottles can stay colder for a longer period of time. Okay, so you can see thus keeping the bottles cold for a longer period of time. Next is aquatic animals are more comfortable in cold water than in warm water. Already the same reason, in warm water there is less solubility of gases, whereas in cold water there is more solubility of gases. Next, liquid ammonia bottle is first cooled in ice before opening it. Okay, so here the reason is cooling reduces the vapor pressure of ammonia. If you remember, vapor pressure is directly proportional to temperature. Higher temperature, higher evaporation, lesser temperature, lesser evaporation. So when you keep it in the cool surface, the evaporation rate of ammonia gas is reduced, and now it helps to prevent the rapid escape of gas from the bottle. Next, we have dissolution of some solids compounds is exothermic, while that of someone is endothermic. So there are two factors which depends or which affects the dissolution process. One is your lattice energy and the other one is your hydration energy. So the relative magnitude of lattice energy and hydration energy during dissolution. Because of this one, the I can say the dissolution of the solid is affected. Now let's see the next question, ninth one. The vapor pressure of a liquid is constant at a constant temperature. So what is vapor pressure? See, if the temperature is constant, that time the rate of evaporation is equal to the rate of condensation. So the concentration remains same. So that is why the vapor pressure remains constant. Next, the vapor pressure of the solution of a non-volatile solute in a given solvent is less than that of the pure solvent. This is very easy question, and this is also important question. So when you add a solute, you see vapor pressure is due to the evaporation of the solvent particles, and evaporation is a surface phenomenon. Now when you add a non-volatile solute, some of the surface particles are now occupied by the some of the surface particles are now occupied by the solute particles. Now earlier suppose 10 particles were evaporating, now 5 particles will evaporate because other 5 are your non-volatile solute particles. So presence of a non-volatile solute occupies the surface, hence fewer solvent molecules can escape, lowering the vapor pressure. Next, non-ideal solutions exhibit either positive or negative deviation from Raoult's law. So that is because of the interactions. This is because the intermolecular interactions between unlike molecules A and B are different from that of AA and BB. It can be either higher or lower. If it is higher, if the interactions are stronger, then we get negative deviation. If the interactions are weaker, then we get positive deviation. Next, an increase in temperature observed on mixing of chloroform with acetone. So if you see chloroform and acetone is a negative deviation, and the reaction is exothermic, means heat is released and that heat is used to increase the temperature. So strong hydrogen bonds occur between chloroform and acetone, making the mixture exothermic, and hence the temperature increases. Next, 13th one, mixture of ethanol and acetone shows positive deviation from the Raoult's law. Ethanol and acetone, you can see ethanol have strong hydrogen bonding, but when you add acetone, the hydrogen bonding is disrupted. So now the interactions has become weaker, and that is why it shows a positive deviation. Next, pure ethyl alcohol cannot be obtained from rectified spirit even by fractional distillation. So that is because ethanol and water form an azeotrope at 95.4% of ethanol. So their composition remains unchanged during distillation because they are having the same boiling point. They are forming a azeotropic mixture. Now you cannot separate them during distillation process. Next, oceans do not freeze. So that is because the seawater contains dissolved salts, which causes the depression in freezing point, and that is why that freezing point is very less and the oceans cannot freeze at 0°C. Next, the boiling point of a liquid gets raised on dissolution of a non-volatile solute in it. So if a non-volatile solute is added, the vapor pressure decreases. Now what is boiling point? Boiling point is that temperature where the vapor pressure of the solution is equal to the atmospheric pressure. Now when the vapor pressure of the solution has decreased, now you need to heat it for a more period of time to match the atmospheric pressure, right? Next we have okay, next, water stops boiling when sugar is added to the boiling water. So again, what happens when you add the sugar, it raises the boiling point of the water, hence the original temperature is no more the boiling point. Now the temperature has increased, so water temporarily stops boiling until the new boiling point is reached. Next, we'll see question number 18. The freezing point of a solvent is lowered by dissolution of a non-volatile solute in it. Again, we have discussed this question. When a non-volatile solute lowers the pressure of the, like the vapor pressure is lower, so you have to now freeze the solution to a lower temperature to meet the vapor pressure of the solid solvent. Next, while making ice creams in a metal or plastic cones, the ice cream sellers put a mixture of ice and common salt around the cones and not ice alone. So it is again the same thing that we have discussed, that when you have the salt causes depression in freezing point of ice, right? So when you have ice cream cones and here you have ice, if you add some salt to that, so what will happen? The freezing point will decrease, right? So that means ice will start melting now. When ice will melt, it will absorb heat from the surrounding and it will make the surrounding more cooler. Okay, and that is how the cones will be cooler or colder for a longer period of time, and it can freeze faster. Okay. Next, NaCl solution freezes at lower temperature than water but boils at a higher temperature than water. Yes, this is because when you dissolve NaCl, it causes depression in freezing point and elevation in the boiling point. So that is why there is a decrease in freezing and increase in boiling point. Next, when fruits and vegetables have dried and placed in water, they slowly swell and return to the original form. So when you have dried water by osmosis or endosmosis, there is the flow of water takes place inside, and that causes the semi-permeable membrane. Through the semi-permeable membrane, endosmosis takes place and it causes the cell to swell. Next, cutting onions taken from fridge is more comfortable than cutting onions lying at the room temperature. So if you have onions in the cooler temperature, so onion, why do we get tears from while cutting onion? That is because onion releases some vapors, some toxic vapors, which is irritant to our eyes. Now if the temperature is reduced, the rate of this evaporation of chemicals is reduced. So less chemicals are evaporated and we get less irritation in our eyes, so no tears come. Next, water from the soil is raised to the top of a tall tree. So now why do water rises? That is due to osmosis, transpiration pull, root pressure and capillary action. Next question is 24. A person suffering from high blood pressure is advised to take minimum quantity of salt. See, when you have high blood pressure, okay, if you take excess of salt, it increases the osmotic pressure of the blood. Concentration increases, osmotic pressure increases, so that means leading to water retention and increased blood pressure. Already the patient is high pressure, and if you eat more salt, the osmotic pressure of the blood increases, that leads to again high blood pressure, right? So that is why you should not eat food with more sodium chloride content. Next, the preservation of foods by adding concentrated sugar solution protects against bacterial action. So if you have a concentrated solution in like near bacteria, what will happen? The bacteria cannot grow because this outer environment is concentrated. The water will start flowing and the cell of the bacteria will shrink. So concentrated sugar solution creates a hypertonic medium causing plasmolysis of bacteria, causing their death. Sorry, preventing their growth, okay, causing their death. Next, measurement of osmotic pressure method is preferred for determination of molar masses of macromolecules. So reason is it is measured at room temperature, and for a very dilute solution also it can give you very large values. Okay, next is when 2 gram of benzoic acid is dissolved in 25 gram of benzene, the experimentally determined molar mass is always greater than the true value. Now you see, when benzoic acid is added to benzene, what happens? There is association, means the number of particles decreases. That means colligative property will decrease, and colligative property is inversely proportional to molar mass. Okay, so then what will happen? If the colligative property has decreased, the molar mass value will increase, right? Now benzoic acid associates in benzene due to hydrogen bonding, reducing the number of particles, so the colligative property gives a higher mass. Next, elevation of boiling point in KCl is nearly double that of the sugar solution. That is because here we have two particles, right? KCl dissociates to give you two particles, increasing the number of particles, while sugar does not dissociate. Next, electrolytes show abnormal masses. We have already discussed electrolytes undergo dissociation into ions, changing the number of particles, and that is why the colligative property value is also different. So now we will discuss the last part, that is the numerical questions. So there are a lot of numerical questions in the question bank, but I have handpicked certain questions which is having a high probability of being asked in the exam. Okay, so you can practice these questions and similar questions you can do. The first question is calculate the mass of the non-volatile solute which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. Okay, and the molecular mass of the solute is 40, and if you calculate for C8H8, this is 114 gram per mole. Okay, so let us see this question. Calculate the mass of a non-volatile solute which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. To reducing vapor pressure, this is the question from RLVP. So what's the formula here? P naught minus P by P naught is equal to XB, and XB can be written as NB by NA plus NB, right? So what is the initial vapor pressure? It has been reduced to 80%. So you can assume that the initial pressure was 100. So 100 minus 80 by 100. Number of moles of B. Now what is number of moles of B? That is the solute. We have to find the mass of the solute, right? So that is given mass by molar mass 40. And what is the number of moles of solute? Sorry, solvent. That is 114 by 114, which is equal to 1. So I can write this one as NV by NB plus 1, right? So that gives me 20 by 100 is equal to NB by NB plus 1. So I have 20 NB plus 20 is equal to 100 NB. Right now, if you see, I have 20 equal to 80 NB and I can have NB equal to 1 by 4. Right now, what is this NB here? NB is given mass by molar mass. So I can write that given mass is equal to NB into molar mass. Right, what's the value of NB? 1 by 4 and molar mass is 40. So I'll get 10 grams. Right, so what is there here? That is 10 grams. Next, we'll have question number 21. The vapor pressure of pure liquid A and B are 450 and 700 mm of Sg. Okay, you have the vapor pressure of pure liquid, right? So this is P naught of A is 450 and P naught of B is 700. Okay. Next is find out the vapor pressure of the solution A. Find out the vapor pressure of solution A if the total vapor pressure is 600. Total vapor pressure is 600. Okay. Next, okay. So how can I calculate like this? That P total is equal to P naught A XA plus P naught B XB. Right. Now you know that we have XA can be written as, sorry, I'll write XB can be written as 1 minus XA, right? Let us substitute that. P total is 600, P naught is 450 into XA plus 700 into XB 1 minus XA. So that will give me 600 is equal to 450 XA plus 700 minus 700 XA. Now if you solve this, you will get 600 minus 100 is equal to, I think 250, I'll get 250 XA and that will give me 100 by 250 XA, 2 by 5. So XA value is how much? 2 by 5, or I can say 0.4. Then what's the value of XB? Because we have 1 minus XA, so XB is equal to 1 minus 0.4, which is equal to 0.6. Okay. Next, we'll see question number 23 here. 100 gram of liquid A, molar mass 140 gram per mole, was dissolved in 1000 gram of liquid B, molar mass is 180 gram per mole. The vapor pressure of pure liquid B is 500 torr, and calculate the vapor pressure of liquid A and its vapor pressure in the solution if the total vapor pressure is 475 torr. Okay. Fine. Let us write down all the value. What is the mass of A? That is 100 grams. What is the molar mass of A? That is 140 grams per mole. Now what is the mass of B? You see 1000 grams. And what is the molar mass of B? That is equal to 180 grams per mole. Now number of moles of A is 100 by 140 and number of moles of B is 1000 by 180. Right? Now what we have is, yes, now we have number of so what is the total pressure? Here one more value is given to me. P naught A value is how much? P naught A is not given. P naught B is given to me, which is 500 torr, and P total is given to me, which is 475 torr. Okay. Now if you see this value is 0.714 and this value is 5.55. Okay. Now what I can do is I can calculate XA here. X I can write 0.714 divided by 0.714 plus 5.55, right? That will give me 0.114 here, and XB will be equal to 1 minus 0.114, which is equal to 0.886. Okay, now I can calculate here like this way, that is P total 475 is equal to P naught A into XA. XA is 0.114 plus P naught B, that is 500 into XB is 0.886. Now if I calculate here, you will get P naught value is 280.7. Okay, and after that you have to calculate the vapor pressure. Calculate the vapor pressure of liquid A and vapor pressure in the solution. So that means you have to calculate PA, which is equal to P naught A XA. Okay, now P naught A value is again 280.7 into XA is 0.114. That will give me 32 torr. Clear? Next question number 29. Calculate the molar elevation constant of water if 0.1 molar aqueous solution is boiled at 100.052 degrees Celsius. Okay, so you know this formula. What is delta TB is equal to Kb dot m, right? Delta TB formula is what? TB, yes, TB minus T naught B. Okay, I'll erase this one. Okay, is equal to Kb into, what is the molality value given? 0.1. Now, if you know that TB value is 100.052 and T naught B is 100, that is equal to 0.1 into Kb. So that if you solve, you will get 0.52 value as Kb. Okay. Next, 31, solution containing 34.2 gram of cane sugar is dissolved in 500 ml of water, froze at minus 0.374 degrees Celsius. Okay, so what is that? Mass of the sugar is how much? 34.2 grams, right? Next, we have molar mass, 342 gram per mole. Okay, and the volume here is how much? 500 ml. And the freeze means TF minus 0.374 degree Celsius, and T naught F is equal to 0 degree Celsius. Okay, and Kf value is how much? 1.87 Kelvin mole inverse. Okay, now if I just want to calculate the freezing point depression constant, here I have delta Tf is equal to Kf into m. M formula is Wb by Mb into 1000 by W, right? So what is the value of delta TF here? That is TF minus T naught F. Sorry, T naught F minus TF will come here because the freezing point of the solution is less than that the solvent, right? So T naught of F is equal to KF value we have to find out, right? Okay, sorry, this is what we have to find out actually. Already answer was given in the solution, but yes, I'll show you how to do. Then WB by MB into 1000 by WA, right? So what is T naught of F? We know 0 minus, what is TF here? Minus 0.374. KF value we have to calculate. WB is 34.2. MB is 342 into 1000 by WA is see 500 centimeter cube, and you know water is 1 centimeter cube is equal to 1 gram, so 500 centimeter cube is 500 gram. So if I solve this, this will give me 2. Then you can see here I can say this is 30, I'll get 1 by 5, right? So 0.374 is equal to Kf into, I have 1 by 5. So if I multiply 5 4s are 20, 5 7s are 35 plus 2 37. So around 1.87 is the Kf value. Okay. Next, we'll go to question number. So actually this one is the previous answer. Okay, so I'll just cross this one. So don't get confused here. The answer is the one which we have calculated. That is your 1.87. Okay, this is from the previous question. Okay, moving forward, here is question number 33 here. Calculate the mass of vitamin C ascorbic acid that is dissolved in 78 gram of acetic acid to lower its melting point by 1.5 degrees Celsius. The Kf value is given here. So here the formula delta Tf is equal to Kf into m. Again, m formula is Wb by Mb into 1000 by WA. I hope you understand what is WB, MB, WA. In the one shot video, I have explained everything. WB is the mass of the solute, MB is the molar mass of the solute, and WA is the mass of the solvent. Okay, so delta TF is how much? 1.5. KF value is how much? 3.9. WB is how much? We have to calculate. Okay, then molecular mass of the ascorbic acid, that also we can calculate here. See, 12 6 is 72. Then I have hydrogen, oxygen is 16 into 6, 96, right? So I will have 176, right, into 1000 by WA, 78. Okay, so you can see once more, I can check. 12 6 is 72, 8, 96, 8 plus 2, 10 plus 16, 10, 17. Yes, I have 176 grams. So what is the value of WB here? So you can calculate it like this: 1.5 into 176 into 78. this all multiplied divided by 3.9 into 1000. Okay, you have 1.5, 176, 78, 3.9 by 1000. Okay, so now you can see here, this one I can write like this: 1.5 into 176 into 78 divided by 39 into 100. Okay, 139, 10 is used here by 100. So 39 ones are 39 twos are, then this 2, 1.5 into 2 is 3. So 176 into 3, 3 6 are 18, 3 7s are 21 plus 1, 22, 3 ones are 3, 4, 5 divided by 100, that is somewhere around 5.28. Okay, answer here is given slightly wrong, 5.07, it will be 5.28. Okay, next 36, calculate the osmotic pressure in Pascal exerted by a solution prepared by dissolving 1 gram of polymer. What is WB here? 1 gram. Molar mass is also given to me, that is 185,000 gram per mole. And what is the volume is given to me? 450 ml. And temperature is 37 degrees Celsius. So to convert it into Kelvin, add 273, that is equal to 310 Kelvin. Now R value is how much? 8.314. I have into 10 to the power of 3 Pascal, liter, Kelvin inverse, mole inverse. Okay. Now we have to calculate what? Osmotic pressure. Osmotic pressure is equal to pi is equal to C into R into T. C is equal to given mass by molar mass into 1000 by volume in ml. Okay. Then I have R into T. So now WB is how much? 1 gram by 185,000 into 1000 by volume is how much? 450 into R is 8.314 into 10 to the power of 3, and temperature is 310 Kelvin. Now if I solve this, you can calculate that the final pressure you will get is 30.9 Pascal. Okay, let's see the next question here. Determine the amount in grams. Okay, just a minute. Of CaCl2, I value is given to me as 2.47, right? And in 2.5 liters, volume is 2.5 liters. Such that its osmotic pressure is 0.75 atm. Okay, and the R value is 0.0821 liter atm, mole inverse, Kelvin inverse. Temperature is 300 Kelvin. Okay, and yes, I think now it is there. We have to calculate what? The W, right? So how can I calculate here? Let's write pi is equal to C into R into T. What is C here? Given mass, right? By molar mass into 1000 by volume into R into T. Now here I am removing 1000 because the volume is already in liter, right? So that is 1, and this is equal to pi value. So I have to calculate what WB. So let us write down WB is equal to pi into MB into volume in liter, right? Divided by R into T. So what is pi value? Pi value is 0.75. MB value is 111. Okay, again, one more thing we forgot here, that is I value, right? We have to substitute I also. So I will be divided here, right? Okay, 0.75 MB is 111. I think that is what is given here. Then we have volume is 2.5 liter, and then R value is 0.0821. Temperature is 300, and I value is 2.47. Now if I solve this, you will get 3.42 as the final value of the mass. Okay, you can easily calculate it. Okay, so students, now we have completed the important numericals and the important questions. Now let me tell you the top 10 do or die concepts, the questions that you must prepare for this exam, okay, for this chapter. So the first very important is the Henry's law and its mathematical formula, okay, mathematical formula, and KH significance. Okay, what is the significance of KH? Higher is the KH, lesser is the solubility. Then Raoult's law statement and mathematical expression or equation. Then difference between ideal and non-ideal solution plus examples are very important here. Positive and negative deviation difference plus example. Why vapor pressure decreases on addition of solute, why the boiling point increases, and why the freezing point decreases. All these questions have been discussed in this particular video, so you need to draw and the graph for this one, graph for boiling point and freezing point, very very important. Next, what are azeotropes, difference between maximum and minimum boiling azeotropes, molarity and the variation of molarity with temperature, osmosis and reverse osmosis, especially the application of reverse osmosis in the desalination of water. Next, abnormal mass and what is Van 't Hoff factor, and then numericals on the colligative properties and Raoult's law. Most probably the question will be asked from colligative properties. Okay. So students, this was the complete, I can say all the important, most important questions for the chapter solutions. And if you do this one video and solve all the questions, then I can guarantee you that this chapter will be done for you. Numericals, I have not covered all the numericals because they are pretty similar type. But if you still have any particular question you have doubt, do let me know in the comment section. And if any other questions also you didn't understand, let me know in the comment section. Okay. So thank you so much for watching and all the best for your pre-boards. And do not forget to hit the subscribe button on this particular channel, because this channel is going to be your one-stop solution for KCT and PU2 2026 preparation. So thank you once again. Keep learning and keep working hard.